sir.
Yes, sir.
Yeah, well, shall we start our class?
Yes, sir.
So, boys, we are in unit number 4. Are we going fast or is that okay, man? Reply me, boys. Are we going fast or is that okay for you? Reply me, boys. Are we going fast? Is that okay?
Okay, sir.
Okay. Let us start our class, today's class. Boys, yesterday we have seen about design and process parameters. I will just go through fastly. Then after that, we will go to our today's topic. Okay. Uh, Design and process parameters. As I said you yesterday, design for a particular 3D printer is important because the technology and operation might be vary for different technologies. What the thing we are seeing or looking before and after this will be about only for FTM in unit number 4 I'm talking. For this we are looking after, but the criteria might be same, but the adjustment might be different. So this is what the topic we have seen last class. The important design parameters we have to take into account for FTM is CAD software and CAE. Proper CAD software and updated properly, data should be transferred to the 3D printer machine. And CAE means we doesn't have any particular analysis engine for 3D printers. Till now, it is not available, and engineers are developing. Okay, it is in a development stage. We have not any particular software. Second one is material. Choose the right material. In FDM, we are using thermoplastics. We are using thermoplastics. Peak, ABS, PLA we are using. Okay. Size and dimension. Size and dimension can be maintained properly by choosing the right coordinate axis, Cartesian or direct. Okay, which one you are choosing, you have to choose properly. And topology means moving around the proper path flow. Okay, next one is dimensional accuracy. Dimensional accuracy can be achieved by choosing the right nozzle. Okay, so that you can get intricate shapes easily, or else some complex shape cannot be achieved, so that it might not satisfy the customers. Next one is surface roughness and surface finish. As you know that 3D printer always give a high surface finish. I'm sorry, high surface roughness. It have to be completed with the post processing work. It have to be completed with the post processing work. So surface roughness cannot be avoided in the printing. After printing, we have to go for the surface finish. Okay, fusing time. Fusing time is nothing but a layer fusing with the other layer. It can be done easily by reducing the time of printing the layer to the next layer. If a layer prints, after that we are going for a second layer. Okay, if that takes a long time, the first layer will get solidified, and second layer is printing over the first layer. It will take its addition won't be a better than it won't be better because it's already the first layer already it's got solidified, so that before complete solidification of first layer, the second layer have to be printed, so that you will get a good fusion. So the fusion timing have to be maintained critically. load criteria. 3D printing products won't have a good isotropic mechanical property, so that depending upon the design and infill, the load criteria might be changed. Sometimes the xy might be good and z might be z axis might be a weaker one. It might change, depends upon the size and how you are printing. Next one is cost. Cost is the most important, and choosing a thing will be mostly because of cost. Mostly all customers, they will choose a product or operation depends upon the cost. So you have to maintain a proper. We have to maintain that properly. As I told you earlier, yeah, in all technologies will you give you good output, depends upon the cost. Depends upon the cost means, yeah, a technology can give you a good output in low cost. Yeah, technology can give you yeah, good output at higher cost. You have to choose with optimization. So you have to get a good output by proper adjustment, by having proper knowledge and adjusting properly, so that you will get a cost effective product. And last one is defect. So defect we have not seen yesterday. As the time was over, we didn't see yesterday. So let us go to the defect. Defects. Most apparent defects can be eliminated or reduced by using a good combination of processing parameters. So it shows that in 3D printing, you can easily avoid the defects. You can easily, completely, you can avoid the defect. You can get a good finishing product easily compared to conventional manufacturing process, but it can be achieved by good combination of processing parameters. It can be achieved only by the knowledge of a operator, so that he should have a thorough knowledge of each and every process equipment and adjusting ability, okay, so that you can avoid the defect. However, some type of defects need to be considered during the design process, as they might affect the performance, and this is what we are looking at it. Depending upon the working of the technology, we have to consider while on design itself, or else there might be a probability of making some errors in the printing. Okay, the first defect is oozing or stringing. I have given the figure. What do you mean by oozing or stringing? Which occurs when trace of small strings of polymers are left behind the nozzle when it's not extruding. It is nothing but a small output being comes after once the process have been stopped. When a layer is completed, layer by layer we are completing. Once the process gets over, the nozzle have to be stopped. The nozzle have to stop the print. Even after the nozzle stoppage, there might be a small oozing of the thermoplastic or any material what you are using comes out of the nozzles in a very thin manner, and it sticks to the product. It might not be a big problem, but it leads to a post processing process. Okay, so which occurs when traces of small strings of polymer are left behind the nozzle when it not extruding. This defect can be minimized by reducing the extrusion temperature and increasing the retraction of the filament during travel times. So it is an avoidable problem. It can reduce by reducing the extrusion temperature and increasing the retraction of the filament. This is how it can be reduced. This defect can be persistent in fabricating features separated by small gaps. Yes, of course, if you have a small strings, while on fabricating, it will create a problem. Even after if you do ordinary post processing, there might be a chance for affecting in assembly. So that you have to be very careful in this oozing problem. This oozing can be removed in post processing by mechanically or by chemical surface treatment. It depends upon the what type of material you are using. Okay. Uh, However, the challenge to accomplish for internal features and joints. So even though where it is present, it depends. Okay, and the A diagram is called oozing. A diagram is called oozing. See, even after finishes, oozings are there. It have been stick to the material and it have to be removed properly, or else it will create some. Just a second, boys. Yeah. The next problem is another important effect is under extrusion. The diagram is here. See here, this might looks like a good output. This might looks like good output, but when you look at here, they have maximizations, and they have shown here. Instead of a proper printing here, instead of a proper printing here, it looks like the string have been collapsed. It have been collapsed. If it is like this, the strength of the material have been reduced and it is not suitable for working condition. It have to be avoided. How this can be avoided? Let us see. This is called this type of problem will be called as under extrusion, as I shown you, which happens when the nozzle is not extruding enough plastic while filling the parts. So the thing is, one thing is when it have been split more, it create problem. The another thing is when it is not splitting properly, when the extruder is not splitting properly, also it will create a under extrusion. That is why it creates some problem. And there are some unintended gaps left between the contours and infill lines. This defect affects the rod's integrity and makes it weaker. Yes, even we can say we cannot able to use such type of product. Okay, these defects can be eliminated by increasing the extruded plastic, which can done by various ways using commercial and open source slices, such as correcting the extrusion multiplier or entered filament diameter. So, how this can be avoided? As you know that in the hot end we are doing drive to force the filament towards the hot end. The thing is, the filament have to be maintained in a proper tension, and enough filament have to be presented, and the proper output from the hot end towards the bow down tube or direct drive should get properly, so that it have to be sent with proper tension and proper output we will get. So it can be avoided. The under execution can be avoided from which. Okay. Next one is governing bonding mechanism. So this is what the actual topic is. We have seen about what are the uh, we have seen about 10 topics of design and process parameter of FDM 3D printer. We have seen about 10. The next topic is governing bonding mechanism. The governing bonding mechanism might be an older topic because it is nothing but how in layer addition, you know that what do you mean by layer addition? We are talking about even we have talked today, even in earlier classes, we have seen what is layer addition. A layer addition might be a big problem if it is not properly handled. We have seen. So even though the topic, a specific topic, have been given in 3D printer syllabus, then governing bonding mechanism. Governing bonding is an important. Sorry, this bonding is important because the output of the total product mechanical properties depends upon the proper layer addition. So it is very much important. That is why they are giving such a high importance in the topic also. Okay, so let us see. 3D printing involves creating a model one layer at a time. The structural integrity of a final print depends upon one layer of the material adhering onto the previous layer successfully. As you know that it is printing layer by layer. A layer have to be adhered properly with the other layer from which a successful. A successful means in mechanically, in we can say in mechanical properties, we can say in good output we can see in if you print or adhere properly, it have been stronger and breaks and also breaks. There will be a formation of cracks or breaks. Why there is a formation of cracks? Why this is happening? Because a layer have been heated and cooled. Okay, then the second layer is printing over the first layer. If the first layer is already cooled down or solidified, again is get heated means there will be a chance for increasing the brittleness of the material. That is why there will be a chance for forming a cracks or breaks. Then what do you mean by layer separation? You should know the meaning of layer separation. Layer separation or layer delamination is refers to the towards the preventing the cracks and improves the steadiness of the final part. Yes, what we have seen on last PPT. To improve the addition, we have to adjust the 3D printer layers so that they stick firmly. It is very much important. Okay, it is not complicated process, but involves a few adjustment to your print and size. Yes, of course, it won't be a big issue, but it is an important issue. Okay, let us see what are the things you have to be carried out, or what are the things you need to be adjusted so that you will get a good output. Okay, let us see. Adjusting print temperature, adjust print cooling, adjust extrusion flow rate, use correct nozzle size, adjust printing speed, clean clogged extruder, adjust the Z axis. So these are the things which you need to maintain to have a proper bonding. Which you need to maintain to have a proper bonding. Boys, are you listening, boys?
Sir,
Okay. First one is adjustment of printing temperature. Why we need to adjust the printing temperature? What is the need of adjusting the printing temperature? So here the adjustment is not the actual adjustment word. It is nothing but optimization, optimizing. Always not adjusting, always optimizing. Because we cannot adjust each and every time, but we have to optimize each and every time. We are not doing this process for compromising of product quality. We are doing this process for improving the product quality, so that the adjustment you are making to have a good output, to have a good output. There will be a change in material. There will be a change in product. There will be a change in design. There will be a change in printing, because ordinary product can be printed vertically, also in horizontally. So there will be change in print. So these are the adjustment are necessary. So what is the need of adjusting the temperature? Because yes, we are using the thermoplastic here. Thermoplastic here, so the output will be, the input will be in a solid form, and output is in the semi-solid, might be liquid form. So that what temperature we are maintaining, it is important to have a good bonding with the second layer, so that the maintaining of temperature is an important one. Then moreover, if you have a closed condition, we can maintain easily, but most of the ordinary printers, we don't have a closed condition, so that the maintaining temperature is a little bit. Okay, a same printer can be print with the closed condition with proper adjustment, and also the closed condition have to be removed and you can print. So all the things can be happen because of the adjustment of temperature. Okay, adjustment. You have scope. Nozzle will not be hot enough to the previous layer. Extruder temperature should be in a proper temperature. I am not mentioning any temperature because depends upon the material what you are using. Even for I am not mentioning here a particular thermoplastic material because if this temperature, even if I sometimes 41, sometimes 42, sometimes depends upon the layer thickness, layer speed, and the every part of them indicating any particular temperature, but you have to know the basic ideas. Okay, that is what I am talking. If the extruder is cold, material manufacturing. When you pour a molten metal from the furnace, it have to be poured within 0 to 30 seconds. Within 0 to 30 seconds. More than that, what happens? The molten metal starts to solidify. Your output of the after 30 seconds, the output won't be good. There might be a chance for forming defects. Likewise, here the temperature what coming out of the nozzle should be hot enough to have a stick with the previous layer. Okay, that leads to a layer separation on the final 3D print. The process of increasing the extruder temperature is done when done with stepwise. When you are increasing the temperature or decreasing, adjusting, it have to be done with stepwise. Start the average temperature and proceed to rise it to interval of 5 degrees Celsius until you notice the change in addition. So they have mentioned here clearly a 5 degrees Celsius, 5 degrees Celsius you may increase or decrease. If you feel that 5 degrees 5 degree is too much, you can reduce a bit. But this 5 degrees Celsius with the research and they have given the details. Okay. And also, I want to tell you one thing, boys. What the data I'm given here are many data given here are I have collected from the research paper. You may directly check with the Google and in any search engine. You won't get these details. What I'm talking today, yesterday, and day before yesterday, you won't get in any search engine, man. I'm looking after many research paper. From that data, I'm taking and I'm giving you in a compressed form. Okay, so that please listen carefully and maintain proper notes to have such data. Okay, because of each filament has its ideal temperature, this testing process will never help you find the best printing temperature for your model. Okay, as I said you earlier, the warmer the filament gets, the better it bonds. Yes, of course, the warmer, it will increase the chance of bonding. If it is colder, the chance is less, so that it will create a problem. Even if it is too much hotter, it would also create problem. So maintaining or adjusting proper temperature is an important thing. Start dialing down the temperature if you notice over extrusion in the prints. So if you feel that over extrusion, you have to reduce the temperature. Okay. So even after reducing the temperature, if you feel again the extrusion is too much, reduce 5 degree Celsius by 5 by 5. As you have done for increasing, same for decreasing also. Next one is adjust front cooling. Cooling is done by fan. As you know that without proper cooling, your output won't be better. I have shown you an image that a printer prints material with cooling and without cooling. Do you want to show that right now, boys? Do you want to show that image right now? Boys, no one is responding, man. Do you want to show that image right now?
Yes, sir.
films with cooling, without cooling. Why this is happening? The melted plastic starts to get falling down due to gravity. So here it have been cooled immediately. So okay, the reason would be the fact our cooler is overworking. As I told you, a layer have been cooled too much. It is tough to the addition of second layer. Here it is at that time have to reduce the fan speed. Warmth will be there that it will stick easily. Boys, are you there? Are you there? Yeah, it was a net problem, man. Do you able to view my PPT?
No, sir.
Wait,
No, sir. No, sir.
is that okay? Is my PPT is viewable, man?
Yes, sir. Yes,
Yes.
sir.
Okay, boys. Adjust extrusion flow rate. If there is too little filament flowing out of 3D printed parts, will have a gap between layers. Adjustment of flow rate is how much um, flow out of the extruder is important. If that is too much, if that extruder is splitting too much, the layer diameter will be higher. It won't stick properly with the previous one because a proper thickness of splitting of the nozzle is an important thing. If it is lesser split, also a problem. If that is higher split, also problem. When you have to increase, when you have to decrease, that is a thing, let us see. Okay, and if there is too little filament flow out of the 3D printers, you will have a gap. If you have a low flow rate, there will be a gap. If there is no more flow rate, there will be a collapsation. So that that often leads to 3D printer layer addition problem that lead cost that if that is such case, you will have addition problem, layer addition problem. Okay, by increasing the printer's flow rate, you allow for a more molten filament to flow out of the nozzle. The more the thread that flows out of the nozzle, the better chance it has sticking. More means a proper, not too much flow rate. Too much flow rate will lead to a collapsation. Okay, you have to avoid such. Then increasing the print flow rate helps to achieve strong bonds. You can increase the flow rate by a certain level. You cannot go more than that because of the size of the nozzle. So you will have a proper flow rate depends upon the size of the nozzle. So you have to choose accordingly. The process should be gradual, increasing the rate at the increment interval of 5%. As we have seen on last PPT, if you want to increase the temperature, increase by 5 degrees Celsius by 5 degrees Celsius, step by step. The same thing also, when you want to increase or decrease the flow rate, increase with 5% by 5%. Okay, a sudden increase and sudden decrement, it will create a clog in the extruder. So that increase or decrease the flow rate step by step. In case, after increasing the extruder temperature and reducing the fan speed, you find the 3D print layers are still not sticking. You can be confident that printing rate of a nozzle needs to be set to maximum. So adjustment between the extrusion and fan speed is an important. Higher extrusion and higher fan speed is not advisable. Higher extrusion with lower fan speed. Okay, that is an important. Always avoid, try to avoid higher speed fan. Use correct nozzle size. Yes, it depends upon the size of the product. Choose the correct nozzle so that you will have a proper output. If you have some intricate shapes, complex shapes, some thin areas, you have to go with thin nozzles. But if you have a general product, a common orientation product, you can go with a higher diameter nozzle. So it will be easy for you. During the printing process, you will need to ensure the fresh layer is pressed onto the previous layer for secure bonding. For that to happen, the layer height is 20% smaller than the nozzle diameter. This is the thing you have to keep in mind. A thing you have to keep in mind is to have a proper bonding, the layer height has to be 20% smaller than the nozzle diameter. So this is what you keep in mind. Don't go beyond that. It will create an unnecessary problem. Bigger nozzle, you will have a good addition, but you won't get a you finish faster, but you won't get a thin areas. That's it. Adjusting the speed. Adjusting speed also important. If that is slow, and the layer will be solidified. The layer will be solidified. If that is fast, it will also create a problem. Fast output will leads to improper flow rate of nozzle, and it will create a problem in the output. So that adjusting the proper printing speed. Adjusting proper print speed is some materials will go up to 100 per second, but for general it will be around 10 to 30 per second. So depending upon the material what you are choosing. Okay. Clean clogged extruder. Yes, we cannot use a clogged extruder. Before starting our print, we have to go for a sample printing, and you have to check there whether there is a proper flow rate or not. If there is clog, you have to remove. And moreover, not only clog, there might be a chance for a dust mite sticking there. It will create a friction, and it will lead to a damaged extruder. So you have to check and you have to clean thoroughly to have a clean extruder. Okay, since the nozzle is very much small hole, you cannot use any other pin or any other unnecessary equipment to clean. You have a hypodermic or acupuncture needle is there. Acupuncture needle is a gentle needle. It is it will be in a good same diameter so that you can use easily. Okay. Try to avoid other type. If it is clogged, you try to use a nylon filament. It will clean your nozzle easily because it will yonking the filament through a cold nozzle and it will clear the passage. Next one is adjust the z-axis to improve the bonding. Always there will be a problem in the z-axis. In general general thing, there will be always problem in, or there will be a weaker section is a z-axis. So that you have to adjust the z-axis. So adjusting Z axis will give you a proper bonding. Because Z axis is always responsible for your vertical up and down movement. So so that you have to adjust properly to have a good mechanical bond. So that is what, man, today's class is. If you have any doubt, you may ask me, man. If you have any doubt, please ask me. No one is responding, man. Is that okay? Is that okay, boys?
Yes, sir.
Okay.
If you don't have any doubt, you may leave, man.